Hello friends! Continuing with the instructional videos about the G100 inverter from the LS brand, today we want to talk about a series of protective parameters that exist in the G100 inverter. These protective parameters are related to the protection of the electric motor, and we want to present the most important ones to you. The first important protective parameter that you need to set in the G100 inverter for your electric motor is related to the overheating of the motor, or in other words, the thermal protection that you need to have for your electric motor. In the G100 inverter, this fault or protective parameter is referred to as ETH, or electronic thermal motor overheating. If we want to activate the ETH parameter or electronic thermal in the G100 inverter, we need to go to parameter PR40, which is the protection group related to protective parameters, specifically parameter 40. We need to specify whether we want to activate the electronic thermal or not. If we want to activate it, PR40 has three options. If it's set to 0, it means we haven't enabled this feature, this protection. If we set it to 1, it means we've activated this feature. And if this fault occurs, the inverter will free run the output. If we set it to 2, when this electronic thermal fault happens and the motor overheats, the inverter will stop your electric motor based on the deceleration you have specified. Alright, but in PR41, we need to specify whether our electric motor is being cooled by its own built-in fan or if we have installed an external fan for it in PR42. We need to set a percentage for the inverter so that it can detect if it goes above this percentage. It will recognize that in the electric motor, there is a heat buildup that is causing our electric motor to overheat. But what exactly is this percentage? In general, the main protective parameter in this inverter is based on the rated current of your electric motor. In parameter BA13, in the base parameter group, you enter the rated current of the electric motor. In general, this inverter calculates its protective parameters based on this parameter, meaning the rated current of the electric motor. When you specify a percentage in parameter 42, this percentage is based on the rated current of the electric motor. For example, if you set this parameter to 150%, it means that if it reaches 150%, if this rated current is drawn from the electric motor, the inverter detects that your motor is now overheating. So the inverter's measurement reference is the rated current of the electric motor, but it also has another parameter. PR43, which is related to electronic thermal continuous, says that in parameter 42, it refers to within 1 minute what percentage of current is being drawn. In parameter 43, it says what percentage is being drawn continuously. For example, if you set 120% in parameter 43, that's 120% of the rated current. If this current is continuously drawn from the electric motor, the inverter detects that an error has occurred called electronic thermal, or in other words, motor overheating. So we need to set two parameters for it. Based on percentage, one is the electronic thermal for 1 minute. How much percentage of the rated current is drawn within 1 minute? And in the parameter 43 also determines what percentage of the rated current is drawn continuously, and if this percentage of the rated current is drawn, the inverter detects the electronic thermal error and cuts off the output itself. But the next protective parameter that we need to set in the inverter for the electric motor is related to overload. In the case of overload error, we have two scenarios. One is that the inverter gives us a warning that an overload is happening in the system, and the other is that it gives us a trip. But what's the difference between a warning and a trip? If the inverter gives a warning, it doesn't cut off the output, just as the name suggests. It issues a warning for you, but if the inverter gives a fault or a trip, then it cuts off the output. So the difference between a warning and a fault or trip in a G100 inverter is this. A warning does not cut off the output and just gives you an alarm, but a trip completely cuts off the output. The first parameter you need to set in overload is this. If you want the inverter to first give you a warning and then trip, you need to set it in parameter PR17, the overload warning. Activate it and set it to option 1 so that the overload warning is enabled. But in PR18, it specifies the percentage. It asks you to specify what percentage of the rated current is drawn for the duration you set in PR19 so that it gives an overload warning. For example, if you set it to 150%, and if for 10 seconds 150% of the rated current that you specified in base 13 is drawn, if the rated current of the electromotor is drawn from the electromotor for 10 seconds, the inverter detects that now it should issue the overload warning. So that's about its overload warning. But if we want the inverter to, when an overload occurs, cut off the output, which parameter should we set? In PR20, it says that if an overload occurs, I will set the output to free run, or deceleration time, meaning based on the DC value you specified. So in PR20, we determined that after an overload error occurs, what action should the inverter take on the output? But in PR21, for overload fault or overload trip, we specify a percentage again, and in PR22, we also set its time. So in PR21, for example, I set it to 180%, and for the time I set it to 60 seconds. This means that if 180% of the rated current is drawn for 60 seconds, the inverter detects that an overload fault has occurred and completely cuts off the output. So we had a warning. There is a warning in the inverter. If an overload fault occurs, it gives us a warning, and in the case of overload, the inverter completely shuts off the output. Well, but if we want the inverter to activate a relay when an overload fault occurs, what should we do? In parameters U31 and 33, we can specify the settings related to the relay output of this inverter. OU31 is for relay 1, OU33 is for relay 2. If we set either of these parameters, relay 1 or relay 2, to the number 5, when an overload fault occurs, this inverter will provide us with a relay output. Now, we can connect that relay output to an alarm or connect it to a signal so that this signal or alarm notifies us that an overload fault has just occurred. All right, so we've now become familiar with the protective parameters that we could set for our electric motor, such as overload warning, overload fault, and excessive heating of our electric motor.